Alrighty, I really thought we'd gone through some of these slides, so we may go through them rather quickly. However, there's only... So anyways, our programs manipulate data. Each piece of data that we work with has a data type. The data type describes what values can be held by the item, how the item is stored in memory, and what operations can be performed on the item. Well, we have no way of knowing how the item is stored in memory, so that's not really that important to us. But what values can be held by the item? You know, if it's a string, it can hold a series of letters, it can hold letters and numbers, it can hold like a phone number or an address or whatever. So if we needed to hold something like that, we would use a string. But you can have data types that are not just, you know, numbers or strings. The turtle that we were working with a couple of days ago is a data type. It's a complex data type known as a class. So you have a turtle object. It's got all sorts of data in it. The values held by the item, you know, it's got its X position and its Y position and what angle it's going at and what color it is and, you know, all of that stuff. So the data type describes what it is and what operations can be performed on it. Like, does it make any sense to divide a string by another string? No, that doesn't make sense because a string is letters, you know, or you're going to divide ABC by, you know, Joe Bob. What does that mean? It doesn't mean anything. However, you can certainly divide numbers. So operations, like arithmetic operations, work great on numbers. They don't work so well on strings. There are two arithmetic operations that do work on strings. I'll show you what they are. I'm just going to open up idle here and not even open up a new file. I'm just going to do this. Name is equal to Bob. And then I'm going to print name plus name. Bob, Bob. Okay. That's called concatenation, when you add one string to another. How about name times 10? Bob, 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 Bob. Okay, so you can do addition and multiplication on strings, but it's not doing math multiplication, right? It's not doing math addition. So even if you did this, x is equal to 13, and then you said y is equal to x plus x, what is y going to be equal to now? Is it going to equal 26 or is it going to equal 1313? Well, it's a string. So, equals 1313. Why? Because it doesn't care that 13 is a number. You know, it could have been Bob. So, the plus sign, when you're working with strings, does concatenation, regardless of the contents. You know, you can make it a smiley. X is equal to, you know, like that. And then you do y is equal to x plus x. And you print out y. Okay, yeah, you get two smileys. So it's not like this could magically figure out, oh, instead of just tacking 13 onto the end of it and getting two of them, I'm going to mysteriously figure out that that's a number and suddenly make it 26. No, it's consistent. Every time you use a plus sign on a string, it does concatenation, which means just to pin the string to each other. So just like we saw Bob become Bob, Bob, and 13 become 13, 13, and Smiley becomes Smiley, Smiley. So, variables have data types. We've seen several so far. String, float, int, and the turtle class is a data type. They have values. You know, 123 is a string, 1.23 is a float, 123 without any quotes is an int, and I'm just going to put a question mark there because the turtle has so many different values, right? The x position and the y position. So the turtle has many internal values called attributes or properties, depending upon which programmer you ask, such as its x position, y position, speed, angle, color, line thickness. One turtle keeps track of all of that. So a variable has a data type, a value, and a name. And I'm sure that we've talked about the rules for names. What are some of the rules for names? What characters are legal? Can you put spaces in a name? Nope. Can you start a variable with a letter? Did I hear yeah? Hope so. Can you start a variable name with a number? No. Nope. Okay. So name, also known as identifier. Letters, digits, and underscores. No spaces. Must start with a letter. Or let's just say must not start with a number. Because you could start a variable name with an underscore if you really wanted to. So, unnamed literal constants. An unnamed literal constant is a value that you've typed literally into the program. That sounds like a dumb definition, but I think I've used it before, so you're going to think that it's just as dumb as the last time I used it. Let's go ahead and launch idle and do a file new. So if I do this, excuse me for a sec, make sure I don't lose my notes. If I do this, volume is equal to, well, here, let's do this. Bottles is equal to 13. I have 13 bottles. Volume is equal to bottles times 16. Okay, great little program. It might tell me how much Coke I have if I have 13 16-ounce bottles, right? These are what are known as unnamed constants. It's a literal. So in that code, 13 and 16 are unnamed constants, also known as literals. And in this case, also known as magic numbers, particularly 16. What does that 16 represent? Well, if you just open this program, you'd have no idea why I chose 16. I was thinking of a 16-ounce bottle of Coke. You know, it could have been anything. Could have been a 2-liter bottle of Coke or whatever. So, what is 16 here? It's the volume of the bottle. In this case, I decided the bottle held 16 ounces. But that's a bad way to do it. You know, what if I was dealing with 2-liter bottles and said I said volume is equal to bottles times 2, and then later on we decided that we're just going to be dealing with 1-liter bottles, and we had to go through and change every occurrence of that 2 because we might use this calculation a whole bunch of different times. We'd have to change them all. So it would be better to do this. Bottle underscore volume is equal to 16. And then you could do volume is equal to bottles times bottle volume. That would be a better way to do it. So, give your unnamed constants a name. Now, in some languages, you have a keyword which says, okay, now that I've defined bottle volume, nothing can change it. You know, nothing later on in the program can change it, so you'd add the word constant there, or final if you're using Java. Python doesn't do that, but you go ahead and give your constants, or what should be a constant, an uppercase name, and every other programmer will understand that that's supposed to be something that's just set once in the program and never changes after that. You're right. Batos. Okay, here we go. Alrighty. Now, why wouldn't I want to make that all uppercase? Because probably bottles is going to be something you're going to ask the user for. So it really is a variable. So try to avoid magic numbers.
another common example of a magic number is pi, but at least we all recognize that. You know, like area is equal to pi r squared. 3.14159 times radius times to the power of 2, something like that. That's a magic number. But there's a way that you can get that constant out of Python by including a certain library. Include math and then access math.py or whatever. So if you weren't going to use that constant, it'd be better to do something like this. Pi is equal to 3.14159, and then do area is equal to pi times radius to the power of 2. Why would you want to do that instead of this? Well, you may use pi 100 times in your program, and then you find out that that wasn't precise enough. You probably know that pi is one of those irrational numbers that, you know, has an infinite number of digits in it. It has no end. And so maybe 5 decimal places isn't enough. Maybe you're writing a space game where your ship is navigating from planet to planet and the distances are very large, and the errors that come from rounding numbers off like that might accumulate over time, and your thing might, you know. Anyways, so it'd be better to define it as a constant and to just use that constant name over and over and over. So if you later on had to change it, you would just change it in one place. Typically, you define your constants up at the top of your program. I'll say named constants. Pretty much if I say constant and named constant, I mean the same thing. Alrighty. Then you have string constants. You know, if we do this, print hello, hello is a string constant, also known as a string literal. You could turn those into named constants as well if you want to. I don't see that as being a big a deal, but if you did this, you know, greetings is equal to hello, and then you did print greetings, excuse me, not in caps, not in quotes, I mean, like that. Why might you want to do it like that? Well, there's the idea in programming of localization. You know, you write your program for an English customer base, but then you decide that you'd also like it to work, you know, for French users. And so you might put a little menu in your program that allow them to switch from French, you know, from English to French or whatever. You wouldn't want to have to go in and edit every single thing in your program to change it to French and then just give them a version that only ran French. You'd like for it to be able to switch between the two. If you had all your constants defined in one place, then maybe when they chose that menu option, they could just change the values of all those constants. That's the idea of localization. Localization is having your program configured in such a way that it can be modified for a new language really quickly. So you can then sell it to, you know, the French speakers and then the Russian speakers or whatever pretty easily. I haven't typed in anything that I consider an in-class assignment yet, so if you've been typing along, that's great, but if you haven't, then it's not like I'm going to turn around and say, oh, by the way, you needed to have uploaded this. So variables are named memory locations. What does memory location mean? If I do this, A is equal to 3 and B is equal to 4, they have to be stored in different locations in the computer's memory. Right? Because if they were stored in the same location, then they would have to be set to the same value. It's like, you know, one street address. One street address can hold one house. You tear down that house, you put in a new one, the old house is no longer there. So instead you get a second street location, one next door, and you build another house. So when I said, where did I do it? Oh, I guess it was in my notes. that a variable has a data type, a value, and a name. This textbook also says that it has a memory location. These are the three things that I want you to remember about it. In some languages, you have to declare every variable before you can use it. You would have to do this. String name is equal to Bob. Int bottles is equal to 13. Float volume is equal to bottles times, I keep doing that, times 1.5. Whatever, like that. In this language, in Python, you don't declare your variables. In some languages, you do what is shown above. Give each variable a type in a declaration statement. If you've programmed in other languages and you kind of wish you were doing that, you can. You could do, I'm going to start off name, and then I'm going to start off bottles, and then I'm going to start off volume, and then later on I'm going to use those values later. So later on, input name, whatever, input bottles, that kind of thing, and volume is equal to bottles times 1.5, whatever, like that. So you can do that. This is what's known as a declaration block, or declarations. Not necessary in this language, but you can. But you do have to, every variable has to exist before you use it, right? If I am here inside the shell and I do print your name is not defined, right? Because I never did this. I never did, I never gave it a value. So you have to have your variable defined. That variable has to exist before you can use it. Regardless of whether you have a formal declaration block or not. You still have to have that variable created before you can use it. So the textbook suggests that we do our declarations in one block. That way you wouldn't have to use a separate, process block to define 8 different variables. I kind of agree with that. I think that's a good idea. So when you initialize a variable, you give it a starting value. It's after you assign it. Your salary is equal to 14.5. Your name is equal to Janita. Garbage is a variable's unknown value. That sounds weird, and Python does not support the idea of garbage values. In the languages I was noting where you declare a variable like that with a data type first, if you did this, int, radius in those languages, well, we've declared the variable. The variable has a type, but it doesn't have a value. But you can be sure that inside it, since it's got a memory location, that location has got some kind of value or not. Might be 0, might not be. That's known as garbage. You don't know what it is. It's an uninitialized variable, so its content is garbage. But you can't create an uninitialized variable in Python, so it doesn't really apply to us. Of course, this textbook is designed for a lot of programming languages, not just Python. Variables must be declared before they are used in the program. Well, not only that, but variables must be declared and have a value before you can use them. So declaring and named constants, the good way to do it is to do all uppercase separated by underscores. That doesn't mean make all your variables look like that. It just means make the constants, sales tax amount, pi, volume per bottle, all that kind of stuff. Things that aren't supposed to change in the program unless you, the programmer, go in and change it yourself. We've talked about modulus, yes? And floor division, 5//2. Okay, good. I know we've talked about PIMDAS, the rules of associate precedence. P is parentheses, E is the exponent, multiplication and division is star and slash, but also slash and division, and then addition and subtraction. Yeah, so modules. We talked about modules. The idea behind a module is you group a bunch of code together so that you could use it over and over. You might write some code that is supposed to calculate, the volume of a certain amount of gas based upon the density of that gas and the temperature that's outside, something like that. Well, that equation requires several different inputs, but you could write that into a module, into a function, and then you just invoke it by that function, and as long as you give it the correct name, then it's going to work. So mathematical functions are good things to put into procedures. Also, anything that's multiple lines of code that you're going to repeat in your program. And what do I mean by that? If you wind up copying 5 lines of code or 10 lines and then pasting it again, well, that's a time to stop copying and pasting and to change that thing into a module so you can just invoke it by one name. So it's a module is a subunit of programming. We're going to call them functions more often than modules. Just know that for now we're going to consider those terms in synonyms. Why do you use modules? It's easier to divide the task among various people. I could say, okay, I want you to write a module that's going to draw a house, and I want you to write a module that's going to draw a tree. That way, if I was going to draw a neighborhood, I could just call the house module 10 times and the tree module 10 times. You could work on the house, you could work on the trees, and we have twice as many people working on the same project. So professional software developers can write new programs by dividing the large program into modules. You assign each module to an individual programmer or a team. So you get reusability. Once you've written that module that draws a tree, you can bring it into another program and then have it draw a tree. And then reliability. That module can be tested. You could specifically test that module and make sure that it works. And then when you go into your next programming project and you want a tree drawing program, you're pretty sure that tree drawing code that's in that module is already ready to go. It's already ready to rock and roll. So it assures that the module has been tested and proven to function correctly. So modularizing a program, you can have a main program. And then in your module, you give it a module header, which is the def statement, and then the body of the code, and a return statement. Naming a module is just like naming a variable. Same rules, except they have to have a parentheses at the end. So when the main program wants to execute that code to draw the flower or draw the house or to calculate the volume of the air, calls the module's name. So the symbol that represents a module call is a rectangle. This says with a bar across the top. Our drawing program uses the bars on the sides. Just remember that it's a rectangle with bars on it, regardless of whether the bars are horizontal or vertical. You place the name of the module inside the rectangle. Draw each module separately with its own sentinel symbols. I don't know what they mean by that term, but let's see if they have an example here. Okay. So this doesn't show any modules. I'm not sure why this page is here, but okay. So start, and then we have all of our declarations. We input the name and the balance. We give some output, we give some output, we give some output, we give some more output, and we give some more output. So we're printing out the address of the place, followed by the customer name, and then the customer's balance. And that's what the pseudocode looks like. Absolutely do not ever, personally myself, do pseudocode in this fashion where I do declarations and then a whole bunch of statements under there that are those declarations. Not a bad idea. I don't teach it. If you wind up turning me in something like that, that's great. I'm not going to count you off if you do it or don't do it. So modularizing a program, statements taken out of the main program and put into a module have been encapsulated. You know what a capsule is, like a capsule of medicine. The main program becomes shorter and easier to understand. Let's see if we have an example of that. Here we go. Here's the same code written with a module. Start, declare, input the name and the balance, and then display address info. And it goes and it does all that stuff. And then when it's done, it comes back and it runs there. Now this red line and this blue line are not actually part of the flowchart. You wouldn't draw them. They're just for the diagram, the slide's purpose. You would just know that when you see this thing that says display address info with a bar on it, or in our case with the vertical bars on the side, that's a function call. It's a module call. And so then it would run over there. It would execute all those lines of code and then it'd come back. So we have modularized this program. Why might we do that? Because we might want to display the address in multiple different places inside the program. Or at the very least, it makes it easy to debug. You know, we would be able to make sure that this part of the code works accurately. And then later on, if we wanted to make it so that the address was not hard-coded, look at this. We've hard-coded an address. Do we only have one customer? ABC Manufacturing? Probably not. So eventually, display address would be needing to have its own set of input and output, but you would be able to go and modify that one module in order to support that. Declaring variables. Oh, and how to do the same thing, come on. In pseudocode. Start, and then your declarations, and then input name and then balance, and then display address info. We see that that's a word followed by parentheses, so that's a function call, a module call. So that means that down here we're going to have a function declaration. Now, just because Python does it, I've been tending to stick in DEF in my pseudocode to mean that it's a module, but strictly that's not necessary. And so this is our module, and it does the outputting of that address, the name and the address of that site, of that customer. And then once it was done with that, it'd come back and it'd print out the customer's name and then their total. So you can declare variables and constants within a module, because a module is just another chunk of code. But variables and constants declared in that module are only usable within the module. All right, it's probably about time for us to start typing together. So if you don't have Python already up and running, go ahead and get it going. Launch idle and then do a file new. So, just because the equation is easy, I'm going to write some code that asks the user for a radius and then print some information about the circle. So, if I was going to do the pseudocode first, I'm going to put 3 quotes up here so that everything that follows, I could do 3 single quotes too, is a comment. the pseudocode would look like this. Start, input radius, calculate area, calculate circumference, print area, print circumference. Now that sure is vague. I'm not even giving you the equations. So we should say area is equal to, and then what is it? Pi r squared. And then the circumference is equal to pi times 2 times radius. Hope that's right. Now the word calculate is a little bit superfluous. We could replace that with the word set. Okay, so that's the pseudocode that I'm going to follow. I may put a comment up here to the effect that that is pseudocode. Alrighty, so I need some definition for pi in order to go on. I would need my declarations block. So pi is equal to 3.14159, or we could find the library in which it is stored and import it, but that's good enough. Now let's input the radius. Now remember, for every one line of code in the pseudocode for an input statement, we wind up writing 3 lines typically. We print a message out, we get the input, and then we convert it to a number. We can kind of combine those, but let's do this. Print, what is the radius? Then radius is equal to input. And then we have to convert it to a number. So radius is equal to float, parentheses, radius. Not that you have to, but I'm going to put a blank line after that pi statement. And then after that radius is equal to float radius, I'm going to put another blank line. And the reason I'm doing that is to just kind of break it up. You know, the inputting is kind of like the opening paragraph to the story. And then we have some other paragraphs of the story coming up, like calculating the area and the circumference. So area is equal to that equation, pi times radius to the power of 2. Same thing for circumference, except I'm going to shorten the spelling of it, because I got it wrong there anyway, so, you know, if I can't type it right every single time, I'm just going to call it circum. Circum is equal to pi times 2 times radius. Then I'm going to print that stuff out. I'm going to print the area and I'm going to print the circumference. So print, parentheses, quote, the area is, end quote, comma, area, parentheses. And then the next line, print, parentheses, the circumference, I am going to use the whole word there, is, end quote, comma, circum. All right, now I'm going to run it. I haven't saved it yet, so File, Save As, Put it in my favorite directory. Feb26.py. Run it. So what is the radius? The radius is 10. I gave it some bad input and it blew up. So I'm going to run it a second time. And it says the area is 3.14 and the circumference is 62. I trust that those are good values. I hope that I remember the formulas right. If not, oh well. So we have a program here. Anybody getting syntax errors at this point? Because the next thing I want to do is to break it up into modules. And I'd like for that to work for everybody. Anybody need? So here's what I want my code to look like. I'm going to kind of scroll down and type something. Don't necessarily type this. But what I would like to be able to do is to do this. Radius is equal to get, I'm going to put spaces here to make it easier to read, get radius. Get underscore radius, parentheses in parentheses. And then I would like to be able to do print circle. Make my program only 2 lines of code long, with this being a function and this being a function. Yeah, I can do that. I'm going to delete those 2 lines though. Okay. Since I want to change this program a lot, I should probably make a new program. So I'm going to do File New, do a save as, and call it the same name just with a B after the end, Feb26b.py. Then take that code from the line pi all the way down to the beginning, copy it all, just highlight it all, edit, copy, and then come into your new one and paste it, but then we're going to turn it into some modules. And really, you could just modify the same one, you know. All right, so here we go. The way we define a module is with the def keyword. Def get underscore radius, parentheses in parentheses, colon. Now everything after the def keyword until the return statement has to be indented. So I'm going to indent that one, indent that one. Notice I'm using the tab, not the space bar. If you use the space bar, that's okay, but you can't mix them up. You can't start using both tabs and spaces. And then I'm going to put a return statement at the bottom. That's going to be the end of our get radius. But it actually needs to return that radius value so that the code that calls it can use it. So return radius. Now I want to take these 4 lines of code and make them their own module. So define print underscore circle, parentheses in parentheses, colon, but I'm going to have to put something between these parentheses, and I'll show you what in just a minute. And then tab all of these things over and then do a return at the bottom of that. Now I've deliberately introduced a mistake that we're going to have to go and fix. The line with the mistake is this one, so I'm going to just put some of those there to indicate that I have to go back and fix it. You don't have to do that, but that's just to let us know. Okay, so then I'm going to do radius is equal to, and this is all unindented now. This is actually, you know, the main program. Radius is equal to get underscore radius, parentheses in parentheses, and then print underscore circle, parentheses in parentheses. So that's our main program. You know, you could put start and stop here if we wanted to make it look like pseudocode or a flow chart. Okay, the code is slightly broken. If I run it, I'm going to get a syntax error. Looks like it's running now. What is the radius? 12. Oh. Shouldn't have worked. Okay, great, it worked. I'll tell you what why I was expecting it not to work. Because we're using a variable here that doesn't exist yet, right? Nowhere above this is that variable defined. And yeah, it's defined here. But that's inside of a function, so that variable doesn't really influence the rest of it. I could change the name of this radius to something else and the program would still work. Because a variable defined in a function is only valid inside that function. And this radius variable here is defined in that function, so it's only valid inside that function. That's why we returned it, so that we could store it here. Now, Python tricked me and it actually worked because the act of doing this statement here did define radius for this one. But I would rather go ahead and make it correct for other programming languages as well as Python. So the problem, as I was expecting it, is that since this variable is not defined at this point, I would want to pass it in as a parameter. So I'm going to go into the module definition of print circle, and I'm going to add a parameter called radius. So that's the line that I changed right there. And that's great and all, but when I run it, now it's absolutely going to get a syntax error. It says line 19. Okay. Missing one required positional argument. So I have to find line 19. It sure would be nice if they put the line numbers down the side like some programming editors don't, but you do have this line number down here at the bottom. You just put your cursor down there and you start moving your thing up and down, and then you notice finally there's a line number there. Okay, the problem is it's missing a positional argument. We have to fill in this parameter with something, so we're just going to pass in radius like that. Now it's back to working. I changed this line right here. I added this variable as an argument to fill in that parameter. Sorry about that. Didn't make it clear enough. Okay, time for me to do walkabout, make sure it's all working for everybody. So we've broken this code up into two modules. There's a getRadius module, there's a printCircle module, and then there's our main code down here. And then there's our declaration up at the top. Next time I give this example, I'm going to make sure that it breaks. I'm not going to show you how at the point where I wanted it to. Okay, so I talked about variables being declared inside modules, only being available inside that module. So I'm going to add one more module here just to demonstrate that. Define test, parentheses into parentheses, colon. Print just a test. x is equal to 3. Print x. So I just added those 4 lines of code. Again, don't add my little comments. That's just for you to see what I changed. And then, before I call getRadius, or after I call getRadius or something, I think I'm going to do it before it. I'm going to call test. So down here, after or before I call getRadius, I'm going to do test parentheses. And then I'm going to do y is equal to x times 2, and then print y. And this isn't going to work. This code is broken. And it says name x is not defined. When I run it, I do get an error message. X is not defined. And it crashed on this line. It didn't crash on this line. It did print just a test. I could prove that to myself by running it again. See, it says just a test, and then it printed out the value of x, which was 3. But then when it tried to do this line, y is equal to x times 2, it said x does not exist. Now why is that? It's defined there, but it's not defined in a place that this code can get to it. It's like this module definition is its own house. And this is furniture inside the house. X equals 3 is furniture inside the house, so somebody sitting outside the house cannot use that furniture. Any variable you declare inside of a function is only available inside that function. If I wanted to be able to use that variable, I would need to return it. And then I could use it. So right now, x is not able to be used because it is not declared before we use it. Because it was only declared in a function. So I could do this. I could put return x here. That's the new line of code. And then I could modify this line here to capture that variable being returned. X is equal to test. And I'm going to put the same kind of comments here to indicate that those are the 2 lines of code that we changed. And now to work. Because we declared that variable there, but then we returned it, and we stored its value there. So we can go ahead and use it. And that did. Now it works without generating a syntax error. So I'm going to be hitting that area, that concept in the future, the idea of things defined in a function being available only in that function. The technical term for that is scope. The scope of this variable is only within that function. X is defined within that function, so it's only available in that function. There are such things in some languages as global variables. If you define a variable up above all of your modules, then that variable is available to all those modules. That's how we got pi to work. However, you'd have to do something special if you want to change the value of that variable. Like if this function was supposed to change the value of pi for some reason, if it changed it in here, it wouldn't be changed for the other one. It wouldn't be changed anywhere else. As soon as it left that module, then it would no longer be changed. So you have to do something special. I'm not going to use global variables very much. The only time I use global variables, and I'm not going to even go there. Yeah, I'll say it. Only time I use global variables is for turtles and for constants. And it works for turtles for a reason I'm not going to describe right now. And it works for constants, but for anything else, I would not use a global variable. So pi is, in fact, a global variable because it's defined above all of our constants, meaning we can use it inside these functions. Looks like we only use it once. So global variables are declared at the program level. That pi is equal to 3.14 was not indented, so it's not inside a module. It's visible to all the modules after it. Many programmers avoid global variables to minimize errors, and some languages do not support global variables. For example, Java does not. C and C++ do. Python does, but you have to use a special keyword if you want it to change that global variable. So the mainline logic of almost every procedural computer program does this. You have some declarations for global variables and constants. That was up at the top. And then you have housekeeping tasks, steps you must perform at the beginning of the program to get ready for the rest of the program. And then you have a detail loop. That's the core work of the program. And then you have end of job tasks, steps that you take at the end of the program to finish the application. Now this is a good point to diverge from what we were talking about to write about looping. Because we did some programs where you entered some input and like calculating the BMI, I think is what it was. And what if you wanted to be able to keep, calculating it? What if, without running the program over and over and over? So here's our code as it exists now. What if we wanted to take this code and to make it so that it would repeat until the user was done? Well, we could do that, but we'd have to put it into a loop. Let's do that. Now this test code is not really important, right? It was just to illustrate something. This is the guts of our program. This is the stuff that we like, these 2 lines of code. Those are the 2 lines of code that we want to repeat. So here's what I'm going to do. I'm going to declare a variable called repeat, and I'm going to set it equal to the word y. And then I'm going to do while repeat equal, quote, y, colon. And these 2 lines are going to be indented now. So you saw what I did? I added that. That was my first change. I added that. That was my second change. And then I indented that line, and I indented that line. And now I'm going to add another line. Input is equal to, nope, I'm getting my syntax wrong, sorry. Repeat is equal to input, parentheses, quote, go again, capital Y / capital N, end quote, end parentheses. So I just added that line. That was my 3rd change. And then my 4th change is that I'm just going to put a done statement at the very bottom, but it's not going to be indented because it's not going to print done until we've exited the while loop. And so I had more than one person ask me how to make your BMI program loop. Keep running, and that's how you do it. You use a while loop. And as long as the variable called repeat has the contents y, it will keep looping. So if the user types in y when it asks the question, it's going to go ahead and repeat. But if they type in anything else, including a lowercase y, then it's going to bail. It'll exit the loop at that point. I'm going to test it out. What is the radius? 10. Go again? Sure, why not? What is the radius? 20. Go again? Nah. All right, done. We might want to change it so that it'll work with either a lowercase y or an uppercase y. And here's what we could do. We could do while repeat is equal to uppercase y. I'm going to change that line. Or repeat is equal to lowercase y. I'm going to remove these comments now. I could keep adding ors if I wanted to. I could let them type in the word yes, Eventually it gets kind of silly because you're, yes with a capital Y, yes, that's all caps, yes with lowercase y, there are other ways to handle that, but just for now, I'm going to go with this. That way I can answer with uppercase or lowercase y's and it works. Or not. Oh, I typed it in at the wrong point. I didn't type in a number where it wanted me to. What's the radius? 12. Do you wish to repeat? Lowercase y works. All right, I think I want to stop there because I think some people had questions about the homework, and so I want to give us time to talk about that. If you don't have any questions, then you can go ahead and leave. Let's go ahead and make a Dropbox for this and upload it. So we are going to have a homework assignment based on the code that we just typed in, but it's going to be incredibly easy. What it is I just want you to print out the volume of that circle if it was a sphere. So that's one more print statement or one more calculation and one more print. And I'll type that up. Let's go ahead and add some specs for that right now. Take the program you entered, February 26, the circle program, and modify it to print out the volume of a sphere. So what are the changes going to be? Change every word circle to the word sphere, so that'll make sense. And then add a calculation to the print sphere, because it will be called print sphere rather than example change print underscore circle to print underscore sphere. Add a calculation to print sphere to calculate the volume. What is that equation? Volume is equal to 4 divided by 3 times pi times radius to the power of 3, I believe. And then modify the print sphere module to calculate and display the volume. So honestly, if you wanted to, you could do that before you left today. All right, let's make the Dropbox. All right, there's a Dropbox 3. Excuse me, there's a Dropbox G for Feb 26. Just a sec. And before I leave the room today, the homework will be put in the Dropbox for homework 4, which now exists.